right, so today is an introduction into logarithms. You might see the button log on a calculator. That is what undoes exponents. And so we need to realize that this is going to be super important going this way and back. So this is exponential form. We're going to be converting it into logarithmic form. And then we're going to be taking logarithmic form and converting it back into exponential form. Just going back and forth to realize how we can rewrite these equations. It's going to be super important moving forward. So let me just do an easy one real quick before we move on. Let's do, because I know we'll have to later, 7 to the third power is 343. Okay? So if I know 7 to the third power is 343, then I can rewrite that as a log. All right, that b moves down here as a subscript, so it's lower. So this 7 is the base of my log. The y moves over here right next to the base, so that becomes 343. And then this 3, the x, the exponent, stays to the outside. So that's how we go from exponential to logarithmic. Going the opposite way, this 7 becomes the base on the right side, this becomes the exponent, and that becomes the number on the other side. Let me show you a different example really quick. All right, hang on. I'm still recording. Awesome. Let me change the color then. Let's say I just have log of 100 is equal to 2. Now, if you don't see a base here, that base has to be 10. It's like if I have x plus 7. What's the number there? It should be a 1. But with logs, if you don't see a number, it's base 10. So I'm going to go ahead and put the 10 in there because if you don't see it, it's got to be 10 anyway. If we're going back this way to exponential form, that would be written as 10 squared equals 100. So you take the base, that becomes the base, that's the exponent on the base, and that's what it's equal to. Here are some color-coded examples. If you have 25 is equal to 5 squared, that would be log base 5 of 25 is equal to 2. That's how we write that. If you have 729 is equal to 3 to the 6th, that would be log base 3 of 729 is equal to 6. Now, if you want to pause this and understand, I've color-coded them just to make sure you know where each term or each number is going. Okay? And that's that. Once again, here we go. This would be log base 1/2. It's okay to have 1/2 as a base. Log base 1/2 of 1/8 will be 3. There we go. Hang on. And then down at the bottom, this would be log base 10 of 1 equals 0. And that's the other thing I needed to mention to you before we go on. You can have log base just about anything down here. Let me put 45 down here of 1. If that number's 1 in a log, you will always get 0 out of it. Okay? Always. Because that's the same thing as saying 45 to the 0 power. Well, anything to the 0 power, almost anything, is going to be 1. Now to get into what you really want from me, which is part of the homework. All right, here we go. Rewrite them in exponential form. Should be quick and easy here. 4 to the second power is equal to 16. Now, most of these you should agree with as well. Now, when we get to the ones with variables, you're not going to be able to agree with them because we don't know what those variables are. Number 2, 7 to the second power is equal to 49. I agree with that one. 2 to the second is equal to 4. And then 256, that's the base, that's the exponent to the 1/2 power is equal to 16, which this is the same thing as writing the square root of 256 is equal to 16, which I agree with that as well. Now, real quick example down here with variables. Just like this, just like we did 4 to the 2 is equal to 16. Y to the x is equal to 131. Over here, this would be y to the negative 8 is equal to x. All right, now I would do, let's see here, number 7, 19 to the x. 19 to the x, the power of x, is equal to 112. Boom, I'm going to skip 8 because you can do that one on your own. Now, 19, I have 1/2. Now, I'm going to use parentheses around this because it's a fraction. 1/2 to the u, not me, but u, is equal to v. All right, and then number 10, you can figure that one on your own. Now, if we're going to log form, that's why I'm leaving these up here so that you can see what's going on. Go in reverse. So, this is the first thing we see. So, I'm going to go ahead and write my log. Blank something is equal to something. Log base something of something equals something. Base something of something is equal to something, and log space something is equal to blah, 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 blah. All right, so that 343 goes subscript right there. All right, so log base 343. Now, that's because that was that. All right, so we're taking this now and going reverse. Whatever the exponent is, that goes on the opposite side of the log. So the exponent here is 1/3. 1/3 right there. And then this number goes inside the log, right there. Okay? And so that's how we're going to do this. Okay? So once again, slower this time. You start with that. 19 becomes the base of the log. 2 goes over here. And 361 goes right there. All right. More examples. That is the base. 2 over here. 64 right in there. Then 64 is the base. Exponent flies over. And then I got 2 in there. All right, let's wrap these up. Let's do a few more here. So this would be log blank blank equals blank. Log blank blank equals blank. Log blank blank equals blank. And then I'll do this one too. Log blank blank equals blank. So real quick, that's the base. So that's the base. Exponent flies over, becomes normal, and then 17. So log base x of 17 equals y. That's how you would read that. That's the base. That's the base. Negative 13 comes over here. A goes in. So log base b of a is equal to negative 13. Okay. 8. Y comes over here because that's the exponent. Flies over. And then I got x. So log base 8 of x equals y. And then last but not least, for me at least, log base 8 of 64 is equal to 2. All right. You can finish the rest of those on your own. Thank you very much for your time.